right, welcome to React Reinvented. It's been 11 years, nothing but 11 years since React came out for the first time. If you were around, you probably remember that it was pretty revolutionary. This was technology, it was like the first time where you had this model where there's this function, you pass on data, it returns a piece of UI. And truth be said, like 10 years later, it was really revolutionary. Like you can see the React model being used in many different areas. You even have now React Native, right? But this model that is so popular, when we got to 2020, a few years ago, what happened is that the React team announced a project called Zero Bundle Size. This is a project that completely changed the model. And a couple of years later, in 2023, we presented in our React conference, in our Next.js conference in San Francisco, the first, sorry, signal went out. There you go. We presented React Server Components in Next.js, which was the implementation of this initial model of zero bundle size project from React original team. Now, this model of React Server Components actually introduced a complete paradigm shift. It's not anymore a function that runs whatever in the client or in the server where you pass on data and you return a piece of UI. Now it's something else. And it unlocks a number of patterns and a number of use cases that allows us to build pretty incredible UIs and user experiences. This is why React Reinvented. It's a paradigm shift, okay? Now with React Server Components, the server is a protagonist in our architecture. And I know that some of these changes are very convoluted. It introduces some complexities, but I hope that after this talk, you have a clear idea of what it unlocks and why it is so cool. So I am Javi. I work as a software engineer for Vercel. I joined Vercel almost 8 years ago now when the company was named differently. Not a lot of people knew about it. I did like tons of contributions that you probably don't know about, but if you are using Vercel and you're using Next.js, you probably are using something that I wrote at some point, which is pretty cool. And well, since I work in Vercel, and I've been working in Next.js and so on, you probably think, oh, okay, this guy is coming from this company, he's gonna tell me how cool the tech is, and he's selling his shit. I am not selling my shit. As a matter of fact, the whole driver of the talk, I want to be the concept of dogfooding. If you don't know what dogfooding is, it's basically use your shit. So you have some products and service in your company, and it's the practice of using your product or your service to find that it fits properly your use cases. And unfortunately, not so unfortunately, but I didn't work a lot with front-end applications in Vercel in the recent years. Most of my work's been done in the back-end, in the compute area in particular, and I didn't have in my day-to-day job, the opportunity to put into practice React Server Components and all of these cool patterns that I want to talk about in this talk. So I decided I'm going to build an application with all of the cool stuff that we have in Vercel to dog food our products and our services. And the thing that I started building like a couple of years ago is a project called SoundSync, okay? So I want to tell you a little bit about why I built this thing and what the use case is, just to show you how I'm kind of like forcing it into being a use case for dogfooding our stuff. I am a user of Spotify since the very beginning. I have tons of playlists. And, but I'm also a user of the Apple ecosystem. And if you are like me, and you went to a run or to a workout or something at some point, and you try to have your offline playlist using the Spotify app in the Apple Watch, you probably know that it fucking sucks. It's terrible. It's really bad. So at the beginning, I was like, okay, I'm going to build this service where I can map one playlist of Spotify into a playlist in Apple. But then I noticed that the matches weren't, I didn't know if the match was correct. So I was thinking, okay, I'm going to build a small player, and I can preview what's going on here. And I did it for Apple, but then I did it for Spotify. But then I wanted to reproduce YouTube, and then I wanted to add Bandcamp. And eventually, I got into this universal player kind of thing that can play pretty much any music track from, not any service, but a good handful of them. And this is like a very clear use case of a single page application, like a client app. But I was thinking, I'm gonna make it React Server components because why not, okay? So the most important thing is that in this is not the app itself. It's not even released, right? The important part of this thing is that it's using Next.js React Server components and all of the cool new patterns. And this is what I want to talk about, and this is what I want to show you. But to get there, we have to talk, even if it is briefly, about the inception of the modern web. If you have been in this job for a while, you probably know that around 2005, we started getting some frameworks, like the first SPA kind of frameworks, JS frameworks. We had Backbone, we had Angular, we had Ember. And all of these frameworks were very helpful to build single-page applications, okay? And this kind of application, as a client, single-page application, is a client-side rendered application. So let's talk about that for a bit, because we need to get a good understanding of what's going on here to see the benefit. So when you do client-server rendering, usually what used to happen, because not a lot of people do this anymore, is that the server sends an empty, there's no routing at all, and it just sends you an empty HTML. Then, once you got the HTML, the browser is going to download the JavaScript. And it's going to evaluate it, it's going to run it. And at that point, usually, you would render a shell, loading, right? Or a spinner. You see a blank page, and then you see a spinner. And this is the first thing that the user is going to see. This is when the first paint is happening. Next, since you loaded the application in the browser, it's going to go to your server in order to fetch the data. Everything is loaded already in the browser. So the page is actually interactive. You can click around, you can do stuff. But you don't have data, so nothing very meaningful. Then when it goes to the server, it's going to go to, let's say, a database query or whatever other service. You need to get some data to show it to the user. Then it's going to send a response back, and the client is going to render the content. You don't see a spinner anymore. You see whatever you want to see. And this is when you are seeing the content painted, okay? Now, the breakdown that we have here, nothing meaningful. It's just a way to kind of see where each event is happening, but don't even take those numbers seriously. They mean nothing. But we can see that the time that it takes for the user to see something is significant. And the time that it takes to see content is even more significant. But there is a pretty obvious optimization that we can do here, right? And that would be rendering the shell first. So this is something in the middle. We never actually got to do this. This was from the same area of single-page applications. But the server can actually go and render the shell right away. You don't need no routing, you don't need anything if the shell is the same for every page. And then you go to the browser, and this is your first paint. You're already showing loading from the very beginning. Downloads the JavaScript, download the assets, and then something interesting needed to happen, which is iterating. The thing that the browser is aiming to paint, or the context awareness that it needs to get, needs to match what you are getting from the server. This is a very naive way of putting it, but this is sort of the concept of iteration for anyone that is not like super familiar with this. Once the iteration happens, which is pretty stupid in this case because you just have a shell, then the page becomes interactive. And then you go to the server. And then you fetch your data. Data comes back. You render the content. Boom, you have the content. So if you compare to the previous one, what happens here is that it's very similar, right? But we significantly moved the first paint earlier in the rendering cycle. The content painted is also a little bit earlier, but it's not very significant. So the next iteration to this thing could be, well, if we are receiving a request in the server and we implemented routing in the server and we were able to render in the server, instead of rendering the shell, we can just render the application. And this is server-side rendering. This is SSR, classic SSR, like we know it. In this cycle, what's going to happen? Well, we receive the request. We know what we want to paint, so we're going to go right away and fetch the data. Once we have fetched the data, we are going to render the app in the server. And then we're going to send it back. During this time, the user is seeing a blank page, saying nothing, right? However, it's supposed to be fast. Rendering, going to the database, it's kind of all right. So this is going to be your first paint. But it's also your contentful paint, because the content that the user wants to see is already there. Next, the browser is going to download the JavaScript. Then it's going to hydrate. And then the page is interactive. And that's it. Okay? So in this case, there are obvious improvements, because the content painted happened way, way earlier than it was when we were doing the shell rendering and when we were doing client-side rendering. Plus, you got SEO already solved, right? Google can index you, and this is like super important. It's been traditionally one of the arguments against using client-side rendering and frameworks like early stages of Angular or Backbone.js and whatnot. So this is how Next.js pages router works, right? Let's see a quick example. How many are familiar with Next.js and Next.js pages router? Almost everyone. Okay, cool. No need to be familiar with this, actually. But the important part in the Next.js, the important thing that we have to understand in the pages router model is that the page is your unit, right? When you make a request against an Next.js application and it resolves routing, it's going to end up pointing to a page. And the page, there are two things that you are exporting when you build a page with Next.js pages router. One is the default export, which is your component, your render. And the other one is a function that we call get server-side props. And this is how you tell the system how you fetch, how you retrieve the data for this first contentful paint in order to render your application. So in this example, we are going to connect into a database, then we do query, we get some products, and then you return the props that this component is going to later receive. However, there is something important here. The function get server-side props, that function runs only in the server. But the component, the homepage component, when you do the first render, runs in the server. And once the application is loaded, it also renders in the client, okay? So components like this in the traditional model of Next.js run both in the server and in the client, but the function that tells how you fetch the data runs only in the server. Now, there are a number of issues with this thing. The first and most important, as from my point of view, is that when you hit the page is your abstraction. This is where you fetch all of your data. So if you have a reasonably complex application where there is like a leaf in this tree that needs certain data and you want to render that data, you have to put it in get server-side props. And that can go very crazy. It's basically is breaking the capability that you have of splitting your application into components, because none of your components has the ability to fetch the data, okay? This is the first and most important problem. And the other important problem is that all of the components that you are rendering in the page are going to be sent to the client. So your bundle is going to grow bigger as you add new components. And it doesn't matter if it's actually going to re-render in the client or not. You're going to send it anyway, and it's going to run anyway. So the question here is, What if what we do is that we take the data fetching code and we put it in the same component. And we make that component to run only on the server. And that is React Server Components. So this is the same component that we were seeing before, but in this case, the data fetching is coupled. It's not coupled, actually, because it has the same concern with your component rendering logic. However, there are a bunch of things here that change fundamentally the model of React itself. For starters, we were saying at the beginning that the beauty of the model is that I have a function, it's just a function, that I can call with some data, some properties, and then I'm going to get a piece of UI from it. Now, this is not true anymore, because this thing is not returning a piece of UI, it's returning a promise that resolves in a piece of UI. So that is very different. The other one is that this component, because our get server-side props function was running only in the server, needs to run only in the server. So it was very beautiful in React, and it is very beautiful in React, that when you change the props of a component, it re-renders automatically, and it handles the UI changes for you. But in this case, how is that supposed to work? Because this is running only in the server. Okay? So I can see the problem, I can see the controversy. How do we re-render a React Server component? And the answer to that question, my friends, is that we don't re-render server components. So when you are aiming at build, you're trying to build like a large application with React Server components, like how the fuck is that supposed to work? Like I have no state, I can't re-render. This is just a static page. And this is why we also have client components. Now, in my opinion, client components is not the best name for this thing, because it looks like it runs only in the client, right? But it's not true. It doesn't run only in the client. This is the traditional Next.js component, like in Pages. It runs in the server first, then it serves to the client, and then the client can re-render it. Okay? The way you declare a component as something that is as a client component is by using this thing that we call a client boundary, using use client directive at the top, which, by the way, is nothing new. We have had use strict for a long time. But the cool thing is that when you need to have state, you need to have hooks, you need to do something with the browser, you need the thing to run in the browser, and you need it to re-render, then is when you make it a client component. So the most reasonable way of thinking about this is to think, well, every component should be a React Server component until it's proven that it needs to be a client component. And the reason for that, this is also something that brought a lot of controversy, because people were saying, oh, you guys are making server components the default. It doesn't make sense because it's the new thing. Well, we are trying to set the guardrails for you to build the best possible application. And I bet you that if the default was client components, your application could be much, much, much better and lighter, but you couldn't get there because you didn't notice that a component is something that you never re-render, and it's a server component. So it makes a lot of sense that it's a default. However, at scale, when you have many server components and you have many client components, how is that supposed to work? Because we talk about the fact that a single component, server component, can't be re-rendered. And a client component can be re-rendered, but in reality, you have many, many different components that are interconnected in a large tree. How does that work? Well, we just said that server components do not re-render, and this is true. This is not very easy to understand at first sight, so bear with me. I'm going to talk about the logical component tree. The way I like to put this is the following. A component has the responsibility of rendering other components. And this is very easily confused with a component being the child of another component, okay? So in this case, for instance, here, My app has the responsibility of rendering server component, client component, server component A, client component A, okay? However, server component A is a child of client component. So one might think that client component is rendering server component. It is not. It is a property that is passed by the upper component. And this is very important to understand because when you think about a component tree in React, it's very easy to get into the pitfall of thinking, well, a client component can't render a server component, so how is it supposed to be interconnected, right? This is the way it is interconnected. Like when you look at this thing and you think about what it is, the render responsibility of each of the components, it becomes pretty obvious that you can actually interconnect server components and client components. I want to show you an example with my application that I talked about in the beginning. This is one of the screens in my application, in my dog fooding application. What you see here is pretty interesting. You have an application component. The application component is rendering a playlist component and then a player component. Those are blue because they are server components, okay? You try to push everything to be a server component, so the playlist is going to be a server component. The items are going to be server components. Everything is going to be server component. However, once the application is rendered and it becomes interactive and I click one song to play, there is shared state between an item here, which is a playing symbol, and this item here, which is the thing that is actually playing. So if we are saying that if you need state and re-render capability, it needs to be a client component, and the rendering responsibility of a client component can't render a server component, how is this supposed to work, right? In idiomatic React, what you do is that you take this state and you put it in the application component. But if my application component has state, then it becomes a client component. So how does it work? Context. Anyone heard of Redux? Okay, I'm sorry for you. Actually, it was pretty cool. I liked Redux. But it's back, right? But not Redux itself, but the pattern of having a context that you have centralized and you are using to pass down to clients, to other components. In the Redux era, the reasoning of that thing was, let's make it so that the component that re-renders are the minimum possible amount. So I can do like handpick the properties that need to trigger a re-render in my components. That was kind of the idea, right? But in reality, you could make a huge application that is just passing props down. This is exactly the same thing. We don't want to pass props down because we can't, because we have interconnected server components, so we need to use the context for this kind of thing. This is, up to a point, a complexity that we have to deal with in this new model until we come up with a primitive that makes everything simpler. But it is required by the model. Now, what you might be thinking is, we didn't change shit. It's the same thing. You have something that is running in the server. So you run the first request, and then it renders the application, and then it shows on whatever. It's not the same. Why it's not? Because we are missing one important primitive here. What I'm saying here is, you have your database query, you render your application, downloads the JavaScript, so you have your first pane and content painted, and then becomes interactive. It's the same thing as before. And this is because we are missing one primitive. We are missing suspense. How many of you have heard about suspense? Most people. Okay, that's good. So suspense is really, really, really cool. It's the primitive that allows you to model asynchronous operations in a declarative way. For instance, if you have a component that is a server component, like this one here, that takes 2 seconds to do something, 2 seconds to render, because it's returning a promise, right? What you can do is to have another component and use this suspense boundary so that you say, until the component resolves, fall back to this other thing, loading, right? So when you run the thing, you're going to see loading, and 2 seconds later, it's going to update automatically. To put it differently, in SSR, traditional SSR, what's going to happen is that blank until I get it. With Suspense, I can immediately make each of my server components render a Suspense boundary, so they show that they are loading independently, and they are going to be resolving independently and showing the content independently. This is much, much, much nicer than the SSR model. So, revisiting, having this in mind, the React Server Component model works a little bit different, because now we're going to render the shell as soon as we get the request. Using the Suspense boundary, we show loading. Okay? What is cool is that the stream remains open. And while it's being sent to the browser, we can already go to the database and start fetching our data. But the user is going to see right away the shell. Then it downloads the JavaScript. Then it hydrates. But in parallel, in the server, we are rendering the content. And once the content is there, well, once it's hydrated, the page becomes interactive. And then the content is going to be served to the client. And this is done through an update in the stream of the same first request. So you get the content painted. And then you have to rehydrate, because you're rendering something that comes from the server and it needs to be present, hydrated in the client. This is as good as it gets. As soon as you are hitting the server, you serve the shell and you go fetch the data right away. And as soon as you get the data, you serve it through the same stream. This has also a number of improvements, or let's call it not improvements, but it's like a number of benefits that we get for free. For example, when you are in the browser, you can use the native cache of the browser. You visit a page, then you click and visit another page, and when you go back, the whole thing is already there. Cache for you. You don't have to do anything, okay? The beauty of streaming. Speaking of fluid compute, so if you are not a Vercel user or a Vercel customer, you can come visit us at our booth later. But this is one of the things that are changing the way in which we consume applications. And this is one of the reasons why we built this fluid compute in Vercel, this product. In case you wonder about this, what it is a number of primitives and defaults for your serverless functions so that they support streaming, they support multiplexing to have more efficient workload management, and basically gives you a very powerful primitive to implement React Server components. And that was the ad. Now, because we are running so short in time, I don't know how are we doing or how much time do I have. This is a countdown, 15 minutes, oh, beautiful. So, live coding patterns, because I am that crazy. Sorry. So, let's see this thing in action. I didn't have a lot of time to prepare this stuff, so bear with me here. I have a demo thing that's running my local. Hi, Codemotion. Okay, so it works, perfect. I'm gonna make the font a bit larger. That should make it, isn't it? Is it good? Okay. So, there are a number, like I said before, there are a number of patterns that are super cool and can be done with React Server components that were not possible in the past. So let's look at a couple of them. This is a React Server component. We are not fetching anything at all here. We are just seeing, like we have like a bunch, some parameters, path parameters, and then we have a search, which is the search query string. I'm parsing this thing so that I get a limit here. Now, wait a second. Yeah, sure. Okay, let's do something here real quick. Let's make this parameters, and then we're going to call this params, and this is actually param search params. Okay, let's go. So what I'm going to do is I'm going to use a helper function that I have to fetch some data. In this case, because it's my testing application, we are going to fetch some tracks here. I have a function prepared so that you don't have to be thinking about, I'm going to change, oh my gosh. Okay, let's change this thing to be fetch tracks. Okay, cool. So you don't have to worry about anything that is not related to the scope of what we are talking here. So this needs a playlist ID, which I am receiving through my parameters. Okay. Jesus. Okay, never mind me. So let's call this props instead. Yeah. Okay, props params. There you go. Now we have params, and then we call this params.id. Okay, so this is going to be my playlist ID. And the second argument is going to tell how many tracks I'm going to be fetching. Let's use the limit that we have over here. Okay. And then the other parameter is the offset, which is going to be 0 for starters. So I'm going to get my tracks here. Okay. And then we're going to render here the number of tracks that we got, just like a first iteration. So let's say tracks, JSON, items, length, and we should see a number here. 30. Okay, not bad. Now, we're going to go and say, let's have a component here. And let's call this playlist items. Okay. So we're going to have some parameters here. Let's call this props. And this guy here is going to receive the same parameters as before. We're going to say like a offset, let's say. With a number. We're going to get a limit as well. We're going to get a playlist ID. Okay. And what we are going to do is render this stuff. We are going to do the fetch here. Right? So the equivalent is like a page kind of thing. And then here, we're going to go and say playlist items. And then we're going to pass all of this stuff. Await, fetch parameters. There you go. What's going on here? Okay, and then we are going to return here UL. We're going to take the tracks, JSON, items, map, item, and then we're going to return an item with a key, and then we're going to set item track name, which is like the title, and then we're going to close the lid here. This is going to be force, I'm sorry, TypeScript. I don't care about you. Okay. And then here we're going to be passing props limit and props offset. And this is going to be my props. And this is going to be the playlist ID. Okay. Looking good. So these are a number of items. Now let's say that instead of 50, I'm going to hard code actually here. I'm not going to use a query. I'm going to say 10. So I see only 10 because I'm fetching the first page. But if this was super slow, what would happen is that, and this is like traditional stuff, like I said, let's wait for 2 seconds, and then I go here, I refresh, I see nothing, it's loading, and then 2 seconds later, boom, I get it. So what we can do is using suspense. So I'm going to fall back to something that says loading. Okay. Let's move this here. Close the boundary here. And then what we should see is loading, and then 2 seconds later, boom, okay? So let's do it again, loading, boom, there you go. Cool. So now let's suppose that I want to render the next page, but I want to make it all in a row because my API allows me to do so. How do I do this? Well, what we can do is that here, we don't have to return a JSX that doesn't include a suspense boundary. We can actually have a suspense boundary as well. So here, instead of returning this UL, I'm actually going to remove this. I'm going to put it here, outside. Let's have it like right over here, UL. It's going to look nicer, UL. And then here, we are going to return this thing that I don't even remember how it's called. This should still be working. But now here, we're going to say, if I have more items, okay, if I have a next page with more data, I'm going to render another suspense cache, another suspense boundary, sorry. We're going to say loading more, okay? And then the component that we are going to render is playlist items, only that this time the offset is going to be the props offset plus the limit or plus the amount of items that we are getting. Okay? So let's see what happens here. Loading more. I am leaving somewhere a semicolon. I don't know where it is. Oh, here. Yes. Perfect. Okay, let's see it again. So I have a pattern where I have like loading, I have 10, loading more, I have 10, loading more, I have 10. This is a very cool pattern. It's a recursion. It's nothing like super new, but it's pretty cool if you ask me. Now let's remove this and make it a little bit faster, actually. Now there is something super nice that I want to show you as well. This is a very nice pattern. Let's say that I want to show at the top of this thing how many items do I have in the playlist. I don't know how many items I have in the playlist until I completely finish the thing. So we are going to create, I don't know if you heard about this before, but there's this deferred pattern. It's like a promise, but instead of having the callback stock, like you can like extract it so you split the responsibility of resolving the promise from using the promise. We're going to do the same thing, but with a generator. So I'm going to create a thing here that I call create deferred generator. Okay? Let's call this deferred. Now the idea is that I take this thing. Let me check real quick what is the type of this thing. Spotify playlist track object. Okay, so we are going to have here something that looks like Spotify playlist, Spotify. Jesus, okay, it's not completing. I don't care. Let's keep it like this. So I'm going to have here this pass as a property, deferred, and we're going to say that this is a deferred. What is the type again? Deferred generator. So deferred generator. Cool of whatever. I don't care right now. Okay, any and any. That's fine. And then we're going to pass it here. And of course, we have to pass it here as well. All right, now the idea is that every time that I got a bunch of tracks, I'm going to use this deferred thing to push them. So I'm going to use this deferred, props, deferred, next, and then we are going to set that the value is whatever I am reading here. Tracks.json.items. And I'm going to be done when I don't have any extra items. So this is basically like pushing data. Now, how do we read this? Well, if you go from the fact that if you start from this suspense recursion pattern, having a synchronous generator that uses this thing is not very difficult. I have a helper here called async called generator component. Yeah, exactly. So this is super cool because you can pass a generator. Okay. Let's call this ini, I think is the way I called it. And this is going to get us, let's call it comp. This is going to be like a normal component kind of thing. And now what we are going to do is that we're going to pass here a generator thing. We're going to do here in the UL, we're going to render this component. And the component is going to receive, if I'm not mistaken, when I have here a generator, and the generator is going to be an async generator. Oh, shit. Let's call this props. And this is going to be async generator, there you go, of any. I don't care what it is. So now the idea is that I can go and iterate through the items that I'm reading from the generator here. And every time that I get a new item, I'm going to yield a new thing here. Okay? And so let's use it. Generator. Oh, shit, I'm running out of time. So we're going to call this generator here. And then this is going to be our deferred generator thing. Okay. Wraps generator. I don't see anything really. There you go. What's going on? Okay. Okay. Actually, I am running out of time. So what we're gonna do is I will show you later how this actually works because I am typing everything as any and that wasn't a good idea. But basically what this allows you is that every time that you yield something, the effect is render the content of a suspense, okay? And then you got the fallback for the next element. The generator is going to replace the content of the thing. So you basically can re-render where you're consuming this and when you're consuming the data and the stream's still open. So to show you an example of this thing taken to the extreme, I want to show you see this? Yes. I want to show you an example that I hope that it works, which is an AI generator of playlists. So let's call this generate rap music playlist for Codemotion 2025. Do you know what it is? By the way, let's call it generate. So this, you can see, is super incremental, but I can start and play right away, and you can see that it's still generating while I am playing the music. Okay? Let's run it again. No, never mind. We are out of time.
Take off the
and yeah, that's pretty much it. This is what I got. Thank you.